An exoplanet or extrasolar planet is a planet outside the solar system. The first possible evidence of an exoplanet was noted in 1917, but was not recognized as such. The first confirmation of detection occurred in 1992. This was followed by the confirmation of a different planet, originally detected in 1988. As of 1 June 2021, there are 4,758 confirmed exoplanets in 3,517 planetary systems, with 783 systems having more than one planet. There are many methods of detecting exoplanets. Transit photometry and Doppler spectroscopy have found the most, but these methods suffer from a clear observational bias favoring the detection of planets near the star. Thus, 85% of the exoplanets detected are inside the tidal locking zone. In several cases, multiple planets have been observed around a star. About 1 in 5 Sun-like stars have an Earth-sized planet in the habitable zone. Assuming there are 200 billion stars in the Milky Way, it can be hypothesized that there are 11 billion potentially habitable Earth-sized planets in the Milky Way, rising to 40 billion if planets orbiting the numerous red dwarfs are included. The least massive planet known is Draugr to thousands of years. Some exoplanets are so far away from the star that it is difficult to tell whether they are gravitationally bound to it. Almost all of the planets detected so far are within the Milky Way. There is evidence that extragalactic planets, exoplanets farther away in galaxies beyond the local Milky Way galaxy, may exist. The nearest exoplanets are located 4.2 light-years from Earth and orbit Proxima Centauri, the closest star to the Sun. The discovery of exoplanets has intensified interest in the search for extraterrestrial life. There is special interest in planets that orbit in a star's habitable zone, where it is possible for liquid water, a prerequisite for life on Earth, to exist on the surface. The study of planetary habitability also considers a wide range of other factors in determining the suitability of a planet for hosting life. Rogue planets are those that do not orbit any star. Such objects are considered as a separate category of planet, especially if they are gas giants, which are often counted as sub-brown dwarfs. The rogue planets in the Milky Way possibly number in the billions or more. The official definition of the term planet used by the International Astronomical Union only covers the solar system and thus does not apply to exoplanets. The IAU Working Group on Extrasolar Planets issued a position statement containing a working definition of planet in 2001 and which was modified in 2003. An exoplanet was defined by the following criteria. This working definition was amended by the IAU's Commission F2, Exoplanets and the Solar System in August 2018. The official working definition of an exoplanet is now as follows. The IAU noted that this definition could be expected to evolve as knowledge improves. The IAU's working definition is not always used. One alternate suggestion is that planets should be distinguished from brown dwarfs on the basis of formation. It is widely thought that giant planets form through core accretion, which may sometimes produce planets with masses above the deuterium fusion threshold. Massive planets of that sort may have already been observed. Brown dwarfs form like stars from the direct gravitational collapse of clouds of gas, and this formation mechanism also produces objects that are below the 13 mJ up limit and can be as low as 1 mJ up. Objects in this mass range that orbit their stars with wide separations of hundreds or thousands of and have large star-object mass ratios likely formed as brown dwarfs. Their atmospheres would likely have a composition more similar to their host star than accretion-formed planets, which would contain increased abundances of heavier elements. Most directly imaged planets as of April 2014 are massive and have wide orbits, so probably represent the low mass end of brown dwarf formation. One study suggests that objects above 10 mJ up formed through gravitational instability and should not be thought of as planets. Also, the 13 Jupiter mass cutoff does not have precise physical significance. Deuterium fusion can occur in some objects with a mass below that cutoff. The amount of deuterium fused depends to some extent on the composition of the object. As of 2011, the Extrasolar Planets Encyclopedia included objects up to 25 Jupiter masses, saying The fact that there is no special feature around 13 mj up in the observed mass spectrum reinforces the choice to forget this mass limit. As of 2016, this limit was increased to 60 Jupiter masses based on a study of mass density relationships. The Exoplanet Data Explorer includes objects up to 24 Jupiter masses with the advisory. The 13 Jupiter mass distinction by the IAU Working Group is physically unmotivated for planets with rocky cores, and observationally problematic due to the SIN-I ambiguity. The NASA Exoplanet Archive INCL